guys, this is Madeline. I'm pre-recording this lesson for you all so that you can kind of go back and listen to it and just have a refresher about the very first science fair meeting and the first science fair lesson. So today we're going to go over the pre-research phase of science fair, and basically that's when we go over topics and pick what we want to do for our project topic this year. And so I'm going to go over just a little bit of vocabulary and a refresher on brainstorming from previous years. And I'm working out of the science fair workbook that I made for you all. So without further ado, let's get started and go over pre-research and what makes science fair project topics a good topic. Okay, let's get right into it. So this is the first stage of your science fair planner. We are going to spend time deciding exactly how you are going to change the world. I think that's how we should view all of our science fair projects because we are doing meaningful research. So now is the time when you really begin to decipher what it is that you would like to study. Scientific research can be done on any topic, no matter how niche, unserious, or unknown your point of interest is. And so y'all have probably heard me say that many, many times, that science fair project topics can be absolutely anything you want. So now it's the time to not think about doing the stereotypical baking soda vinegar volcano projects or any other project that seems simple or that you aren't interested in. We're not going to do that. Instead, you're going to pick a topic that you are actually interested in. This chapter, we're going to discuss the key concepts of what good science fair topics are, what makes them good, and then we're going to go over instructions and like work steps for how you're going to narrow down your topic and how you're going to decide what it is you're going to do. So the biggest roadblock for almost all science fair students and scientists alike is finding a proper and testable science fair topic. So I agree. I think we're doing the hardest part of our research, honestly, right now. When you look at science fair projects, usually once you decide what you're going to do, then everything else kind of follows. You do your research and you naturally ask questions, and then all of a sudden you have an experiment and you're kind of all done. But finding what it is you're going to test kind of is the hardest part. So we're doing the hardest part and we're just going to set ourselves up for success. So to begin, to tackle the proper part of making like a proper science fair topic, as I stated before, any topic that you're interested in will make the cut. But to help you narrow down your choices, I recommend that you first look at your hobbies and ask yourself, what are you involved in at school, outside of school? Do you play sports? What is your favorite subject? What do you spend your time doing? Do you have any hobbies? What do you want to pursue when you grow up? Are you curious about how something in the world works? Or generally, like, are you curious about any field? Is there any field that you haven't learned about before? Those are all great questions to ask. And then the answer to these questions will give you insight to your current interests and passions. The biggest deciding factor of picking a project topic, remember this, is whether or not the project is personal and meaningful to you. You ultimately are the deciding factor. Not only does personal investment in your project make the process more interesting and fun, but like I've said before, y'all probably heard me say this, science fair projects are judged by judges that are real people who are going to wonder like what your story is. And when they're judged, it's very important to see how innovative and personally impactful they are to you. So the judges want to hear your story about how you encountered a problem in your life and the way you use science to innovate it and make life a little bit better, or easier, or different in any way, how you've used science in application to a real world problem. And we just want to make sure that this project is something that you really want to study. So keep that in mind, please. This basically means that the judges will want to see the passion and curiosity behind your project and how it applies to your daily life. So that's just for the general big broad ideas, but I know many of us already have those big broad ideas from earlier in the year. Some of us are doing a continuation project. Some of us know what it is we're going to study, but not really something specific. So once you have a couple of big, broad, and relevant categories of interest, the next step is to ask yourself, what is a problem in my life, in these categories, or in the world that I see and want to address? It can't be stressed enough that science fair projects should address should all address an attempt to solve a real world problem. I probably say this many, many times, but ultimately that's what we do in science fair. We use science and we take a problem in our life and we solve it. And so projects you've done previously, they are all real world projects that address real things. The purpose of science is to come up with solutions and explanations for events and observations of daily life. All these things that affect you and us and everyone. All scientific innovations, machines used on a daily basis, and inventions of all kind were discovered in order to solve a problem and help people and basically make life a little bit better. So thus, we're going to use science fair and use your innate perspective to pick a real world problem that impacts you, that is in your field of interest, and then we're going to investigate it over the course of the next 5 or 6 months and make our project. So in simpler terms, you're going to find a problem that you notice, brainstorm things you can do to test or find a solution, or you can brainstorm the outright solution to that problem. So like I said, many of us are kind of at this step where we have a problem or we have a big field that we need to turn into a testable science fair topic. And so that's what this next part is about. That's really all it means when I say a proper science fair topic. What the proper means is it's something that we can build an experiment around. It's something we can test. So to move on to the testable aspect of a science fair project, while all project topics are good topics, not all project topics are testable. In any scientific research, it's very important that you make sure you're actually testing something. This means you can't simply compile a bunch of research on your topic. Your project has to attempt to discover or prove something new. Your project may test something that is diagnostic to widen the breadth of applicable knowledge in a subject. Basically, what that means is that your project might test information, like it might just test one new thing. So the best way to explain this is an example. So if you were growing plants and you wanted to determine if shaking on the ground of the environment of the plant, like if you planted a plant and then shook the pot a bunch while it was growing constantly, like maybe like seismic activity, or if you lived in an area with a bunch of earthquakes, you could see if shaking has any effect on the growth of a plant. That would be objectively doing a diagnostic test to prove something new. You're not really looking for one way or the other, whether like how it's going to change the plant. You're just testing generally to see if there is any effect at all. So that is a very good angle you could take on a science fair project, just testing something broad and seeing if there's any effect. You might also compare multiple things in order to find a best or worst method. So what that would look like is, back to the plant example, you could test different watering schedules for a plant to see if watering your plant 2 times a day versus 5 times a day, to see which one has the best resulting plant growth. So you're trying to optimize, or you're trying to find the best way that you can schedule watering your plants to help farmers out there, to help at-home planters. And this is very simple project topic like examples, so I'm sure the answers to these questions are out there on the internet, but you get the gist as a best or worst method test. The next angle you could take, it might also use objective information available to create a new method or a new discovery for that field. So what that could look like is a data study. I recommend students do this a lot of times if you're looking at something medical, or if you're looking at something that you might have a hard time testing on your own. Scientists often do a lot of research outside in these fields that you're interested in, whether that be medicine or whatever the case may be. Scientists do a lot of research and they put data out on the internet just for other people to use, for other people to look at, and to prove up their research. You as a scientist can use that data and look for patterns in the data that they weren't really focused on. So for example, if you were looking at a medical research paper and they had a bunch of data where they took blood tests for some disease or something like that, they might also record blood type. And so you could look at blood type and see among all of their participants if there was any pattern in the blood types, if participants from certain group had certain blood types, and you could just try to draw patterns from that. So you're taking information that's out there and you're using it to create some new idea or support some new conclusion that you have. So that's a very good angle that you can often take. And then lastly, another great angle that's very common is testing. That testing can be done to identify issues with a pre-existing standard of operations. So that kind of sounds a little weird, but the gist of that is that you can do a test to point out a way to do something better in life that you've noticed. So, for example, a very silly example, how do we toast bread? We use a toaster. And so, you as a scientist can look at that and then say, hey, I think that there is a way to make toasters better. So you can try to change the user friendliness of the toaster. You could put the toaster on a timer. You could change the mechanism of how the toaster toasts the bread. You could make it battery operated instead of electrical, and then see if that is better than the original design. So you're identifying some kind of issue and you're trying to change it to make the invention or to make the practice or what we normally do a little bit better. Um, so those are like common ideas, just to give you some avenues that you can brainstorm through. But ultimately, the goal of your project is to make a new discovery in one very specific area of your topic that has not been studied before. These new findings and contributions are what will make your project valuable to the scientific community. It cannot be stressed more that if you have a project idea you want to pursue, Google exactly what you plan to test and see if it is already common knowledge. So this is really important. We don't want to be rediscovering information that's already out there or redoing things that scientists have already discovered. As a scientist, it's your job to find new information. And as a science fair sort of as a science fair scientist specifically, we want to be looking at projects that haven't been already tested. We want to contribute new information, and we want to solve problems that haven't already been solved or improve on those solutions. With some kind of new innovation. So, a great way to test this, like I said, is if you are thinking of your idea, type that idea up into Google. So, for example, if your question, your science fair problem, and your science fair idea is to see what is the best watering schedule for pea plants, if you Google that specific question into any search engine and then see what it says, if there is like clear specific information on websites that say, well, you should water your plants 3 times a day, Monday, Wednesday, Friday, then there's already information out there. And so, what I encourage you to do then is to take a slightly different angle on that project. Maybe you could test how often, like, you could test if climate changes that watering schedule, if living in the northern hemisphere or southern hemisphere has any impact on how you should best water pea plants, something like that. That's a new take on the same idea. So, key point is that we need to make sure our projects are testable. And we're discovering something new that hasn't already been done with our science fair topics. And that's how you make sure that your topic is a quote unquote good topic. So now for an example, a student is doing a science fair project and they enjoy many different things. Specifically, they like engineering, medicine, and studying earthquakes that have happened in the past. So these are our big, broad ideas that you guys might already have. Then the step one is going to be to narrow it down a little bit. The student is going to be doing a project about earthquakes, but they're going to be studying a specific engineering perspective on the earthquakes. So how earthquakes affect engineering, maybe buildings, something like that. That's their slightly more narrowed down field of interest that they're going to be addressing. So now the student decides to come up with a science fair idea, and we're going to determine whether or not this idea is testable and basically whether or not this is a good idea. So under step 2 is the student's idea. Because of the student's extensive interest in earthquakes of the past, they will research how specific geographic regions deal with earthquakes through the evolution of their civil engineering practices. So basically, the student wants to study how different areas of the world that have earthquakes, how they address that in their buildings. Like, do they build, they're going to do research on how different areas of the world handle earthquakes and how they build their buildings differently because of earthquakes. So the question now is step 2 a finalized testable project idea? The correct answer to that question is no. Step 2 shows the topic of a research project, but ask yourself, can an experiment with variables be done to prove or disprove or find information that helps solve this issue, the issue being earthquakes? It is imperative that you can set up an experiment to either compare how different things work or improve upon a working process of a pre-existing work. So, step 2, we're only doing research about how different places in the world handle their earthquakes. But that information's already out there. We're not taking that information and creating something new, and we're not comparing things either. So you're not having a testable question that an experiment will be able to evaluate. So that's why step 2 doesn't really work. So in step 3, we're going to fix that. So in step 3, the student decides to research if geographic regions experience earthquakes in the same way, and how local geography impacts the way that structures must be built to sustain earthquakes. So they want to test, they're going to probably compare data from different parts of the world, different geographic parts, and they're going to see if the data from the earthquakes, how they experience them, if they match, if certain areas have more severe earthquakes, if certain areas have less severe ones, something like that. They're going to compare those different experiences, and then they're going to then see how the local differences, I guess, how those differences impact the way that they build structures. And so again, we're going to compare the different methods that people use to combat earthquakes in different parts of the world. And then from there, they're going to draw conclusions about how different types of earthquakes in different parts, how that impacts the way that they're handled and how people set up precautions and what different engineering like safety measures are taken. So notice how for step 3, it is possible to design an experiment that compares the style of structural supports that are best suited for earthquake activity in different geographic areas. Step 3 also solves an aspect of the real world problem. Step 3, you are finding information that combats the devastation of earthquakes that other people can use. Other people can look at their information and see that certain areas of the world handle things differently, and then they can see why. So lastly, for step 3, you can't simply Google step 3 and then come up with like a clear, distinctive answer to those key questions. And so that's what makes this third step over the original step 2 a good science fair topic. It's testable, it's very specific, the information isn't out there, and you're combating your real world problem. So this page, to start your brainstorming, a good resource for broad topics is the science fair category list. Look through the categories below, research the topics that you think you're interested in, and pick a couple that you would like to do a project in. I included this long list of all the different topics. Some of you might be familiar with it, some of you might not. I've picked in the past, I've helped y'all pick your topics, and I will do that again this year. But I just, in your brainstorming process, I want you to have these topics available so that you can think of problems in your life that kind of fit into these categories, and pick a couple of different categories that you think might be interesting and try to practice creating a testable project idea within that field of study, and then see if you're interested in it. You don't always have to stick to one or the other. Try new things and kind of figure out what you're interested in. This might be a good place to start. So go ahead and pause the video. You can go over these. People who have done projects in these categories in the past can kind of speak up and share, and then that way you guys can just have a little bit more of an idea of different variations of what you might want to do. So after you kind of have your big broad idea. This is a brainstorming idea map. And you may have done this before if you've done science fair before, but I do think that it's important to go back over it every year and kind of go through this process just to make sure that your science fair idea is important to you and it's also testable. So just kind of follow along, open up a Google Doc, and then follow the instructions while we go over it. And also, like, after I finish going over the instructions, y'all can work on this up until like next meeting, and this will help you figure out what your topic is going to be. So, highlight any of these like big areas of interest that interest you. The list below is like sports, music, space, nature, medicine, all these different broad topics. And then also, if you have other hobbies, write them down, list them out. So that way you're kind of looking at something on your Google Doc and you have this bank of possible like options. And then from that big list of options, then pick top 3 interests. So three of these big ideas that you would really like to kind of focus on, that you might actually see yourself doing a project in. And then from these 3 interests, pick 2 problems, 2 of these real world problems that you actually want to solve. So an example of this, if your big interest, big topic is sports, a problem that you have observed can be, how can athletes avoid dehydration in the heat? So pick two problems that are kind of like that, that apply to one of those 3 interests that are in your life, they're personal to you, something that you're curious about, something you'd want to test. And then remember, after you pick these problems, we have to double check. A science fair project needs to test something new or compare solutions. For each of the problems above, brainstorm if you could design an experiment. So ask yourself the questions: am I measuring or comparing something? Could I do that? Could I change one factor, and see what happens? Could I change something about the situation and see if there is an effect? Could I create or improve upon this method or solution that's already out there? So ask yourself these questions, and if you can see yourself doing an experiment that answers those questions, then that is a good topic. Your topic is vetted and approved. And then finally, for our last step, take both of these 2 topics that you could really see yourself doing a project on, and then type those ideas into Google, like specifically all written out in a sentence, and then see what research has already been done. See if anything like is a direct answer to your question. And don't don't look at the AI overview, because that's going to try to compile information and give you an answer that may or may not have been tested and like actually researched. So don't focus on the AI overview, but actually look at all the websites underneath of whatever Google tells you, and see if there are any like studies, or see if any website like tells you the answer or gives you instructions, or that information that you're trying to look for, if it's already out there. And if it is already out there, then what I suggest is just take a little bit of an angle to it and test something that's similar or relevant, but just a little bit deeper, or just change one thing. Make it a little bit different from what they've already tested. And that's just how you can make sure that you're doing original research. After you've done that, and you've made sure that this topic is indeed like new information, then you can go back onto Google, and then look at all those sites that popped up, because that information on those sites, they're all relevant to your project, and so it's somehow related. And copy and paste those sites that are interesting after you've read that into your Google Doc underneath of your topic, and then kind of briefly summarize in about 3 sentences underneath of that link, just generally what that site's telling you. Like, you can say, hey, this is related to my topic because it discusses plants, or it discusses watering schedules, and this person, you could talk about like what the source is, whether it's a research paper, and just how it's relevant, so that you have it. Because the very next step after we pick our topic is doing as much research as we can to become experts in our topic, and make sure that we're asking the right questions. Make sure we don't have to change anything about our question before we do our experiment. So right after this, y'all are going to be working in really deep research within a research document. But at this point, just pick a bunch of websites so that you have a place to start when it's time to do your deep research. And then finally, this doesn't have to happen today at the meeting, but the goal of all of this brainstorming is to then pick one narrowed down topic that is going to be your science fair idea. So ultimately, once you've done all of this research and everything, think about it. Think, what is it that I want to study this year? And it's your job to then narrow it down and pick your topic. So the last thing that I did want to note before the end of the video is that I know a lot of us are doing continuation projects or have an idea that we do want to test. Specifically for the continuation projects, on top of creating new science, like new scientific information, new discovery, we can't test something that's already been done. In science fair, big rule is that we can't repeat projects that we've done in the past. So in the past, if you've tested any project that you've tested, you can't repeat and test the same thing or try to test the exact same conditions. Even if you do like more of the experiment, even if you change little things, we have to be testing ultimately something different. That's what separates the project. So a good example of this is my project in the past. My middle school project, I was testing multiple types of natural meat preservatives. And so my very first year, I tested olive oil, vinegar, and baking soda to see which one extended meat shelf life the longest. And I found that olive oil was the best natural preservative. So the following year, my next project, I couldn't test the same thing, but I wanted to go deeper and find more information to still address that same problem about finding a natural meat preservative. So what I did is I compared how different oils preserved meat. So I compared soybean oil, olive oil, and coconut oil to see which oil, or if there was a specific characteristic of a specific oil that made it the best meat preservative. So just like that, we can't test the exact same thing, but you can go deeper, or you can pick a specific conclusion that you made and then take an angle and try to do more like detailed research about that. You can also, if something went wrong in your experiment, or if you had conclusions that you really couldn't explain, you can do your project this year to answer those questions that couldn't be answered, or to answer new questions that your results gave you. Just like I had questions about why olive oil worked, so I looked at different characteristics of oils. So just like that, come up with some kind of project idea that is it addressing the same big real world problem, but that is different from your previous experiment. Alrighty, that's basically all I have. I hope that these videos were helpful. I hope that this gives you a clear idea of what to do. You have your mission to go pick your topic. I hope y'all have a wonderful meeting, and I hope to see you at next meeting and to continue to do these videos for y'all. Alrighty, bye guys.